Hello InfoPerson, this is Anton, and today we have some really exciting news from the TRAPPIST-1 system. Or I guess exciting because this time researchers were able to observe another planet, and this time one of the planets that's technically inside the habitable zone. But more importantly, the planet is considered to be one of the most Earth-like planets, with one of the highest chances for having habitable conditions on its surface. And so let's talk about these new discoveries and these new observations. But first, before we start, a very brief review of some of the previous observations from just the last few months, and what the scientists have already discovered about TRAPPIST-1, which is even today is still the most famous exoplanetary system, just because of these 7 terrestrial worlds in its orbit. And so first of all, when it comes to stellar distances, it's not that far, 41 light-years away from us, and orbiting one of the most common types of stars in a galaxy known as a red dwarf. But here was really the sheer number of planets that was so surprising. 7 so far have been confirmed, with potentially another one, 8th one, somewhere on the outskirts. And you can learn more about this 8th planet in one of the videos in the description. And because the planets here were tightly packed, because they were orbiting in front of a star, and because they were all terrestrial, this made it a perfect target for the James Webb Space Telescope, with the main purpose being studying the atmosphere of these worlds and figuring out if some kind of a terrestrial planet around a red dwarf can maybe have hospitable conditions. And so in some of the previous videos we've discussed the first few observations from the TRAPPIST-1b and TRAPPIST-1c, and more recently TRAPPIST-1d. And so for TRAPPIST-1b, the closest planet, mid-infrared observations with JWST revealed a lot of complex data with 2 main possibilities. Either no atmosphere, so basically a bare rock, or some kind of an unusual atmosphere with thermal inversions, potentially similar to Titan, containing hazes that reflect a lot of light. But the bare rock explanation is currently the most prevalent. For TRAPPIST-1c, the information is less detailed, but here the initial observations also seem to reveal a barren rock with potentially minimal atmosphere. Whereas the TRAPPIST-1d was revealed to have no Earth-like atmosphere, with the telescope failing to detect key molecules like methane, carbon dioxide, water, and oxygen. Molecules that are pretty common in the atmosphere of Earth. And though it still might contain something similar to Mars, which would be extremely thin atmosphere, or maybe even have high-altitude clouds like Venus that hide the atmosphere, right now the most likely explanation for TRAPPIST-1d and TRAPPIST-1c is also unfortunately a barren rock, with these studies essentially ruling out that either TRAPPIST-1b, c or d could be Earth-like planets, and showing a lot less promise for habitability around red dwarfs compared to previous assumptions. But today our focus is on TRAPPIST-1e, a planet that always stood out because it orbits within the habitable zone, within the Goldilocks zone, where the temperature might be just right in order to contain liquid water that could then maybe lead to the atmosphere and maybe even habitable conditions. But as always, the universe loves to keep us on our toes, with the recent findings being somewhat insightful but also somewhat challenging when it comes to conclusive evidence. And here I actually wanted to briefly discuss why this is challenging, because it is important to understand in order to understand the data. Unlike our Sun, TRAPPIST-1 is a red dwarf and is also relatively active. It's actually only about 9% the mass of the Sun and only about 12% its radius, and so it's also relatively dim in optical light. Most of the light it emits is in the infrared, which means that planets do have to orbit really close in order to receive enough heat for liquid water. But there's a really important difference between TRAPPIST-1 and the Sun. TRAPPIST-1 is an active red dwarf that experiences a lot of frequent flares, with its surface covered in a lot of bright star spots. And this actually creates a lot of noise, or what's known as stellar contamination, in a lot of observations involving the star system. And so for researchers studying the star system, this makes it super difficult to figure out what they're looking at and what they're observing. Because sometimes it's not certain if they're looking at a planetary interaction or something coming from the star that might completely change the data. Likewise, as you can see from this image, we know that the planets here are most likely extremely different from anything in our own system. Because they orbit so close to the star, it's quite likely all of them are tidally locked. One side is always facing the star, the other side is forever in darkness. And they also seem to have different composition. Based on the density analysis, we know that all of these planets are much lower in density compared to Earth. And so they might contain a lot of lighter materials, even things like water, or possibly just have much less iron in their core. And that includes TRAPPIST-1e. Here, because the mass is about 70% of mass of our own planet, but the radius is about 92%, the density is 4.8 gram per centimeter cube, or about 87% of the density of planet Earth. And though in terms of size this planet is very similar to Earth, the gravity here would be a little bit lower, actually approximately 82% of Earth's gravity. And in a lot of previous studies, and based on a lot of assumptions in the last few years, TRAPPIST-1e was basically thought of as the most likely planet to potentially contain habitable conditions, or at least contain liquid water. As a matter of fact, here's what NASA imagined this planet to be back in 2018. Here they imagined a lot of seas, some lakes, quite a lot of clouds, and of course, atmospheric conditions not so different from Earth. As a matter of fact, out of approximately 10,000 planets identified, this was considered to be one of the most likely Earth-like candidates. And because it was much farther from the star, it would also receive less X-rays, less UV radiation, and thus have a much higher chance to maintain permanent habitable conditions. And so here, by observing the light from the star as the planet passes in front of it, the method known as transmission spectroscopy, researchers can then figure out what kind of molecules it contains in its atmosphere, if there are any. And that's because some of these molecules are going to slightly change the light coming from the star, giving it a very specific spectrum. And so as the gases in the planet's atmosphere absorb specific wavelengths, they're supposed to leave behind a very unique fingerprint, telling us what chemicals it contains. And so now, in September of 2025, we got two new studies. Studies based on 4 initial observations of TRAPPIST-1e using the James Webb Space Telescope, but studies, as I mentioned before, encountering major difficulty. Because as I mentioned, stellar contamination is a huge factor here. And this seemed to dominate the initial spectral analysis. And so to try to resolve this, scientists use what's known as Gaussian processing to try to filter out some of the star's variable light and to try to isolate potential planetary signals. And the discovery in this case is somewhat complex, because even after correction, their data basically shows us this. It shows us a somewhat flat line. And so what exactly does this mean? Well, there are 2 potential explanations. One, this could be once again some kind of a barren rock. No atmosphere, nothing on the surface. Or it could also have very heavy atmosphere with very high altitude clouds completely hiding any gases below. But based on these observations, we can rule out certain possibilities with a lot of confidence. For example, we're pretty certain now there seems to be no hydrogen-based atmosphere. This is something we find on gas giants like Neptune, Uranus, Jupiter and Saturn, and this is consistent with earlier predictions and earlier observations. At the same time, this data disfavors very thick CO2-rich atmosphere similar to Venus. So this is not a Venus-like world either. As a matter of fact, because there seems to be no CO2 observation whatsoever, this possibly excludes Martian-like atmosphere as well. But on the more intriguing side, there is still a possibility for some atmosphere, and specifically nitrogen-based. Here, these observations do not exclude atmospheres rich in nitrogen, and possibly even containing trace amounts of methane and maybe something else. And that's based on some of the preliminary analysis showing some kind of a preference for methane absorption in a nitrogen-rich atmosphere. But here it's also important to state that this discovery was not statistically significant. In other words, this was not certain, mostly based on the stellar contamination once again. Here there was just a hint of methane, but we do need more data and more observations. But if there is methane here, what exactly does this mean? Well, if confirmed, this would be super exciting because a nitrogen-methane atmosphere would be very similar to what we see on Titan. But in this case, in a much warmer environment. In other words, we might have a Titan-like planet with potentially super bizarre conditions on the surface. With the other question being, okay, what about habitability? Well, the observations here don't rule out the possibility for this to be habitable, but right now the data seems to favor some kind of a colder scenario. As in, the planet is probably a little bit too cold for liquid water and may only exist in extremely specific areas, such as basically right underneath the starlight, the location referred to as the substellar point, which would basically make this planet look kinda like this, although we're not sure if there's going to be water or not. And so right now we just don't have a definitive answer yet. But the good news is that we're going to be getting additional observations very soon. There's a new James Webb program underway right now that's going to observe 15 additional transits of TRAPPIST-1e, collecting more detailed data and allowing us to finally figure out what's happening here. But what's even more exciting is that here we'll get to observe both TRAPPIST-1e and TRAPPIST-1b practically at the same time back to back. And so since we know TRAPPIST-1e is a bare rock, it will become possible to confirm the transmissions from both planets, just to see how they differ, allowing researchers to figure out if TRAPPIST-1e contains anything on the surface. So here TRAPPIST-1b will be used as a kind of a stellar contamination benchmark. And so by having these much stronger constraints, in the next few months we'll hopefully get additional information and very likely conclusive information on whether this is some kind of a titanium-like methane world, or if this is again a barren rock with nothing on the surface. And so just to sum up everything, even though TRAPPIST-1e is still the best candidate for habitable conditions somewhere out there, and is possibly the best candidate for liquid water and Earth-like atmosphere, right now based on the star's activity it just makes things a little bit more difficult, and atmospheric detection seems to be very challenging. And while we know there is no hydrogen atmosphere and no carbon dioxide atmosphere, based on early hints of methane and nitrogen, in theory this could still be some kind of a really exciting world, possibly even containing bizarre liquids not so different from Titan. And so either way, the journey and the exploration continues, and with every new observation is going to bring us closer and closer to figuring out what the system is like, and obviously also helping us understand our place in this wonderful universe. But at least for now, that's all for today. Thank you for watching, subscribe, come back tomorrow to learn something else, support the show on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access and a few secret videos. Alternatively, you can also support this channel by buying the Wonderful Person t-shirt that contains JWST as one of the designs. Stay wonderful, I'll see you tomorrow, and as always, bye bye.